Thank you. Okay, so kicking things off here, I'm going to start with a quick mention of our speaker here. Joseph Grosso, he's the machine learning engineer at Loblaw, and he's here to present Accelerators Made Easy, improving MLOps at Loblaw Digital using Vertex AI. And then for those who had attended some of the workshops we had, there was a Vertex AI workshop earlier as well. So we'll be sending some videos out about that. But this is interesting because he's actually tying it into an actual application within a business context. We're really grateful for Joseph for sharing with us today. Joseph is the machine learning software engineer at Loblaw Digital, working on the data science platform team to design reliable, scalable, and maintainable data systems. Joseph recently graduated from Queen's University with a bachelor's degree in applied mathematics and computer engineering. Prior to joining Loblaw Digital, Joseph worked in data engineering roles for Scotiabank and L3Harris Wescam. So Joseph, thanks again. Thanks for joining. I'm looking forward for you to share this experience with Vertex AI in industry. And sorry again for the confusion earlier, but we're glad to have you back, and I will pass the mic over to you.
Yeah, no worries at all. Just before you go, could I quickly see who the MC is? If there are any questions in the chat, I won't be able to see them.
Absolutely. So I'll be sticking around and we'll help out with any questions that you have.
Perfect. Thank you very much. Okay, so I will share my screen. Okay, I believe that we can see that now. Nice. Okay, hi everyone. Thank you very much for the introduction. I am Joe, and I am a senior, I am a machine learning software engineer at Loblaw Digital, working on the data science platform team. And today I'm going to be presenting to you a little bit about our implementation of matrix multiplication that we use at Loblaw Digital for our model training. And so what I'm going to be doing is going through how we implemented the use of Vertex AI in our systems, and going to be demoing some of the code that we use to do so. Okay, so a little bit of background on Loblaw Digital before I get into it. Loblaw Digital is the section of Loblaw's corporation, which is behind the digital presence of all of Loblaw's different banners. So PC Express, Shoppers Drug Mart, Beauty Boutique, Joe Fresh, any of those sites, if you've been on them, you've used a Loblaw Digital product. And the data science teams at Loblaw Digital drive the personalization of the customer experience at Loblaw's online stores. And as a member of the data science platform team, I'm working to improve the operations for our data science teams so that they can create even better insights for our customers. One of the projects that we've worked on as a data science team to help personalization at LD is creating the targeting engine, which enables personalization of our inspirational feed content. So as you can see here, this is a screenshot from the PC Optimum website, where you can see at the top of your page when you log in, you'll see inspirational content. So for example, as you can see here, you'll see inspirational video, and you also get different links to inspirational content here. So all this is customized and personalized to your own prior purchases. And so we take in information about you that we know of you as a customer through PC Optimum and give you personalized recommendations for this content. The engine behind this personalized content is the targeting engine. So as I said before, we personalize the content based on your customer shopping history. So what products do you typically buy, your web analytics, so what are you clicking and loading on our front end, and the offers that we give you on PC Optimum. And then we generate the recommendation in the targeting engine and store those personalized content recommendations for the PCO mid-tier to grab when a user goes to the PC Optimum site. The PCO mid-tier grabs those recommendations, grabs the top content from Contentful, and gives that to the front end. But the main portion of the pipeline that I wanted to focus on today was our user product embeddings. So this is the part that the machine learning is focused on, and this is where I come in. In this pipeline, we use matrix multiplication to multiply user and item embeddings. So to back up a bit, we have a sparse matrix of user and item mappings based on a user's purchase history for different items. And we use a technique called Bayesian personalized ranking, or BPR, to factorize these sparse matrices into embeddings, which we see here, that you have item embeddings and user embeddings. And what we can do is we can multiply together those two embeddings to create a dense item and user matrix. And so a specific user item location would represent the predicted user's affinity for that given item. So to calculate this item and user embeddings matrix multiplication, we use Google Cloud Platform Accelerators to execute this. And this is done weekly on the GPUs in the Loblaw Digital Kubernetes cluster. So in this pipeline, we have a few issues as it currently stands. So number one of those is that the matrix multiplication job frequently fails, which means that our user and item affinities aren't updated. This doesn't break our system because we still have the historical clicks or the historical data from past week's runs. However, this is obviously not ideal since we want to have the most updated data for our users to consume or to use for our predictions, excuse me. Another issue that we run into is that the GPUs on the Kubernetes cluster are used by many other data science workloads, which means that we have to coordinate with other data science teams to make sure that we're not interfering with their runs when we rerun this job. So that basically means that our issues are twofold. We have a job that frequently fails, and we have an issue with rerunning those jobs when they do fail. And then the other complicating factor is that this matrix multiplication job takes a very long time to complete, around 12 hours, using 2 GPUs in our cluster. So that's obviously something that we want to look into when we're trying to see if we can improve this. So the question we're asking ourselves is, are we using our resources effectively in GCP? And in particular, the data science platform team's question is, can we improve the reliability and scalability of the matrix multiplication pipeline by using Google Cloud Platform services more effectively? And because you're watching this presentation, obviously that answer is yes. We are using Vertex AI in our systems to power these workloads now. So Vertex AI, to back up, Vertex AI is Google Cloud Platform's unified platform for AI and ML. It offers many features, to power machine learning workloads for both beginners and experts in machine learning. I've given a full list of all the features that Vertex AI offers over here, but I'm going to go through a few of them at the bottom here. So number one is Vertex AI Workbench, which is similar to Google's Colab, but runs within the cluster or runs within your Google Cloud Platform projects, which allows you to spin up Jupyter notebooks using compute engine resources. Vertex AI data labeling allows one to provide a PDF to a group of human labelers, and that allows these people to that allows users to label this data for you, so you don't have to go to the trouble of trying to label it yourself. Another very useful feature is Vertex AI Feature Store, which I'm sure has been spoken about at this conference, but essentially what a feature store does for you is it allows you to store features for machine learning workloads, which is similar to a data lake, but allows you to do it specifically for machine learning tasks. And then Vertex AI training is what we're going to focus on today. Custom training on Vertex AI allows you to run your own machine learning training code in Google Cloud Platform. So the Vertex AI platform provisions your compute resources from Google Compute Engine to run your Docker images, which contain your training code. This gives access to all the GPU accelerators that are available on Google Cloud Platform, of which there are many. and also gives you access to custom CPU resources as well if you want high memory, high compute, anything that you want basically for your specific job, whatever fits your use case, you can take use of. Another perk of GCP is that the custom code requires only minimal changes to be compatible with GCP. Everything is integrated very well with the platform already. And the model inputs and outputs are easily sent to Google Cloud Storage. And finally, the pricing is only tied to the number of machine hours your training code uses. So if as soon as you're done with your job, those resources are spun down and are dealt with for you. So what is our solution with Vertex AI to the issue that we're having with the matrix multiplication pipeline? So our solution is to implement this with Vertex AI instead of using the Kubernetes GPUs. And as you can see, the architecture on the right is similar to what we have now. And the results from this are, number one, we broke the reliance on the Kubernetes cluster that might be interrupted by other jobs, which was a huge operational issue for us when trying to fix the failed jobs. Number two, jobs can be commissioned on command. So whenever we need to start up a new job, it's very easy. And third one, which is another perk of this refactor, was we updated job runs in only an hour and a half, so 8 times faster than the 12-hour runtime before, with the use of 1 GPU versus the use of the 2 GPUs on the Kubernetes cluster. And I want to be very clear here that when we were running this, the GPU, it's not that Vertex AI is any faster, it's just that we found optimizations within our own code to fix the issue of the slow runs. And the final thing is that this adds very minimal cost to our GPUs for us. So it's only around $2 per run, costs around $2 per hour to use the compute resources that we're using, and then is not adding too much for us. So that is a very useful part of the solution. Okay, so I'm going to now do a quick walkthrough of the code, a high-level overview of how the pipeline works and how we use it within Vertex AI. Just to focus in on the architecture that you saw in the last slide, what we basically have, how we set this up is we send our Dockerized training pipeline to container registry. And when we want to run our job, we use either a bash script or Cloud Composer. There's many different clients that you can use. You can even use just a curl request to Google Cloud. You send it to Vertex AI with all the specifications, all the arguments you want to pass in, the type of compute you want to use, the location of the container that you want to use. And then Vertex AI provisions the compute resources, spins up the container, and then runs your code. And within our code, what we do is we pull in the 2 matrices that we're trying to multiply, the user and item matrices. We also pull in the row and column labels. And after the matrix multiplication is done and we grab the top 600 or so top recommendations, we map the users and items to those outputs and send those as a TSV file to our cloud storage. So diving into the pipeline, the first step that we have is just pulling embedding matrices and labels from the GCS bucket. As you can see, these files are huge. Each of the embeddings we use is around 128 embeddings or factorized or embeddings within the factorization. With the items, we have around 200,000 items in the Loblaw's catalog that we are training on. And we have around 10 million user wallet IDs that we are training this on. So once these things are pulled, we multiply the user and item matrices and get the top K items for each user. As you can see here, what we're doing is we are extending the neural network module within PyTorch. And this allows us to use the PyTorch library to implement this matrix multiplication and distribute this matrix multiplication over many GPUs if we would so like to in the future. We don't need to right now because the job is running quite fast, even without the use of GPUs. But in the future, if we'd like to use more training jobs or train more models in Vertex AI, that would be useful. And so as you can see here, what we do is we grab the top K vals and initialize the first matrix, which is the item matrix. And then in forward, that's where we're computing the actual matrix multiplication. We use torch map mul and then grab the top K using torch top K functionality. And then we return the top K values from this service. And what we're doing here is we grab this data in batches, or we output this data in batches so that we're not computing a matrix that's 10 million rows by 200,000 columns and taking up all of our memory. Next, we then map each of the top K item indices to labels. So as you can see, this is what a sample output may look like. We have the user IDs with a tab in between, and then we have a sorted list of all the items using their article IDs to identify each of them. And so we're gonna have many files that look like that sent to GCS. And finally, you see that we've output them to GCS. And this is what it looks like. We have many of these .tsv files that are output. And this is then later consumed by a downstream process, which sends this data to BigQuery. So the most important part, or one of the most fun parts, I would say, is actually running the job in Vertex AI. What we're doing here is essentially just instantiating an AI platform, taking a custom container job and running it. It's very straightforward to do this, and there's many options, as I said before, to do so. But it basically allows you to create this job in Vertex and choose the exact compute resources that you'd like to use, and then gives you status updates throughout and outputs the logs to Cloud Logger as well, which is very useful. So this is where I talk about the implications of matrix multiplication, this pipeline, and Vertex AI for Loblaws. So this was the first time that Loblaws has used Vertex AI in this capacity. We haven't used it for training before, but we found that it's an incredibly useful solution to us for the pressing needs that we have for this GPU resource pool. We don't have the ability right now to run compute as we need or provision the compute that we need in all of our data science projects. And using Vertex AI, we'll be able to unlock that power and use Google Cloud Platform much more effectively, and as it's sort of intended to be used as a way to scale up your compute power as needed. So in conclusion, we're going to unlock more of the power of GCP using this framework, make the data science workflow better for everyone, and improve the reliability of our DS jobs so we can focus on making good insights for our customers. And with that, that is all I have for you. So I'm going to open up the floor to questions.
Questions here, and if I bounce off, Raz's going to jump in. I just had some issues here, but we do have a lot of questions coming in. So do you have any, sorry, Adar should ask at the start of the presentation, what order does the shape of the matrices extend to?
What order, as in the rows by columns number? So if we were to multiply this all in one shot, we would be multiplying a 200 or a 10,000 row by 128 column matrix by 128 row by 200,000 column matrix. So 200,000 times 10 million is a lot. So what we do is, instead of doing that all at once, we do that in batches, as I said in the presentation.
Just, Joseph, in case I cut out, if you go on the right side in the session tab, you can see the questions coming through. Hopefully my connection. Fatin asked, do you have a CI/CD pipeline for this? Can you describe how it's being productionalized? For
sure. So we use GitLab at Loblaw Digital, and so we use GitLab CI to productionalize many of our models. And this is no different. Essentially, what we do is we have a step for turning the, building the Docker image and then sending that Docker image to GCR. And then we also have Docker images, or excuse me, GitLab CI steps for also production. Cool. Okay. We also have steps for testing the image as well. So
cool.
yeah, using
maybe I'll just ask you to throw up the slide just so we don't have the matrix view.
Right. Fair enough.
Yeah, thanks. And then who generally takes up responsibility of monitoring or operating usage of the compute resources?
So we have SRE teams that monitor compute resources, but the platform team also takes on some of that responsibility as well. So it's a mix, but in general, it's the infrastructure teams like platform and SRE that take on those responsibilities.
Great questions. I like how that's more of a team breakdown. These are some of the questions that we get as well that are very fascinating because there's obviously no methodology for the team breakdown of monitoring and operating the usage of these resources. For example, Yan asks, did you choose implementation in PyTorch specifically for multiplication speed up? Would it not be possible in TensorFlow?
Yes, it is possible in TensorFlow, and we actually did do an initial run where we implemented it using TensorFlow. But as a team, we decided that the team had more experience using PyTorch in the past, and PyTorch also has a lot easier, I'd say, support for using multiple GPUs. And so it would be totally doable in PyTorch, you're totally right. But we just decided that because of the team's experience with PyTorch and because we think that the interface is better for distributed compute, we thought that it would be a good choice to use PyTorch.
Okay, so thank you for that, by the way. That's a great answer. Vino asks, can you please tell us how you would productionalize this pipeline with GCP? How
we would productionalize this pipeline with GCP? Well, our GitLab runners run on GCP. I'm not sure totally I understand. We essentially use Google Cloud Platform for all our services. I guess one implementation detail would be that when we run batch jobs, we mostly use Airflow. So Airflow is powering a lot of our data science workloads, especially in our batch jobs. So that is what we use for our scheduling software to productionalize these models.
Okay, and maybe if you have any other further questions, yeah, you can shoot them in. Sukant asks, how often do you have to recalculate matrix mult?
So we schedule the job to run once per week, but as it's currently implemented, it's failing much more often than it should, essentially. So what we would like to have is we would like to only run it once per week, but basically what's happening is we have to rerun it every once in a while because it fails in production, which is a horrible, bad, not good outcome. So in the future, we're excited to have this be productionalized and to start working for us. The Vertex solution, we'd like to have that productionalized so that we can use that instead of our current solution.
Mm-hmm. Suleiman asks, what was the biggest challenge you faced with Vertex AI?
Challenge that we're still facing right now. So this final version of Vertex AI is not currently in production yet. We've made a POC that we're very happy with, but we still need to figure out the permissions issues, which is probably my least favorite part of any software project. So passing in a service account has been difficult, but I don't have many other big gripes with the Vertex platform right now. It's fairly straightforward to use. So yeah, it's not a great answer to your question for gripes, but yeah, I don't have many at the moment.
Yeah, maybe what we'll do is we'll touch base in a couple months once this is in a production environment. We can get an update. I think that would be very helpful for folks.
Exactly.
Yeah, Jennifer asked, $2 a run is actually not too cost effective. Could you shed some light on the direction of future optimization on GPU computation?
Yeah, so in the future, we would like to, there are a few things that are part of this run that we would like to improve on. Number one being that the actual size of the output files is huge. So every time we're writing these CSV files, I would say it takes about 75% of the runtime is just uploading this data to GCP, because we have these massive CSV files that have a lot of redundant information in them. And so a quick win that we could have is updating this to instead of using .csv files, we could use Avro to serialize this and make it a little bit smaller. And then we wouldn't be using as many resources, or we wouldn't be using the Vertex resources for as long. So that is one update that I want to productionalize. But right now we were focusing on getting this into production. And so we were working with the legacy data type that we were given.
Well, Joseph, thank you so much. I look forward to catching up with you again. I'm grateful for you sharing where you guys are at with your journey with Vertex AI. I'll encourage folks to check out the workshop as well that we have, which we'll release afterwards as well. But hey, congratulations! I know you're new or somewhat at the beginning of your journey in this field and in your professional career, but it sounds like you're already building out some battle scars and have some fun stories to tell, and you're getting some good experience. So congratulations, and I hope we hear from you again.
I appreciate that, man. Hopefully I'll be speaking again here soon.
Yeah, and thanks all for all the great questions, Vino, Adarsh, Glenda. Appreciate the applause. And we'll see you folks in the sessions tab on the left. Also, just a quick reminder, please remember to go visit some of the expo booths. They're giving away some free stuff, some information, some links, some documents, some PDF files that are all really interesting, but also just some prizes. And you'd be surprised, not that many people actually go ahead and click on that. So your chances of winning $100 gift card, pair of retro Nike Jordans, I think is one prize, Bose speakers and so on, are pretty good. So I hope you get a chance to check that out. But anyways, Joseph, thank you so much again. Thanks folks for joining, and we'll see you in the next sessions.
Thanks everyone.